जी। वीडियो बनते हैं। Assalamu alaikum. Welcome to the webinar. I guess we should wait for another 5 to 10 minutes so that everyone will join and we will then proceed with the webinar. Thank you. Assalamu alaikum. Let's proceed with the webinar. So I'll first of all welcome all of you. I'll introduce to you our trainer in a while. First of all, I'd like to talk about a Smart City Lab. A Smart City Lab is conducting this webinar as we identified this little labs in between the educational platforms that we are exposed to and the actual industrial requirements of skill set and the requirements that we should have in our toolbox of our skill set. So Smart City Lab is a lab, part of a consortium of 9 labs. It is a part of National Center of Artificial Intelligence. National Center of Artificial Intelligence is as I mentioned, there are 9 labs which constitute the whole National Center of Artificial Intelligence. It is a government organization which basically has taken the initiative of introducing the artificial intelligence technology and revolutionized the industries in Pakistan with indigenously developed technology to promote learning, to promote the use of technology within Pakistan. So having said that, I will tell about some projects of Smart City Lab. Smart City Lab has various initiatives ranging from social initiatives to technological initiatives. We are primarily inclined towards computer vision, robotics, and embedded systems. So all these things actually coincide on one point that we somehow lack between the bridge between the actual deployed technological tool sets that are being used in industry and what we are being actually taught in our academic area in universities in different genres. So to bridge that, one of the main topics is, of course, the robotic operating system. It is somewhat a different people are actually reluctant to incorporate the robotic operating system ROS in their early stages of education, not primarily because it is very difficult to understand or comprehend, but it is somewhat different from what we are exposed to in our conventional education. So to bridge that, today we are having this webinar. In this webinar, we will be actually talking about what ROS is, what are the basics, what is the learning path that we should follow. Actually, ROS offers a little steep learning curve, which might create some reluctance in every individual to take that route. We are going to demystify that and we are going to talk about how to just embark on the journey to learn ROS. So having said that, if that is making sense to you, you are going to enjoy the session that will be delivered by Mudassir Jas. Mudassir is a research assistant at Smart City Lab and he is working on various projects, including AgriBot. So AgriBot is actually an agricultural robot project. We might talk about it towards the end of the session again, but right now I'm excited to hand over to Mudassir, and Mudassir is going to talk to you about ROS. So over to you, Mudassir.
Thank you, Shamila, for the introduction. My screen is visible. My voice is clear. So today we are discussing our new course, which will be start from the next week. And today I'm discussing what is the ROS and why we are using ROS in the robotic system. So basically our course name is Introduction to Robot Operating System, which is ROS. So before we discuss ROS, we have just see the highlights or the statistic related to robots. So according to some of the reports, it is estimated that by the end of year 2025, the market size of the smart robot will be around $17,561 billion, which is a quite huge amount if we convert it into the peak year. So it's a huge amount, so it's a huge on the robot system. And and other thing is that if we calculate the compound annual growth rate of the smart robot, it will be around 22.3%, which is a quite high percentage. And other report which was stated in the year 2019 by the ABI research group, it is estimated that 55% of the robots by the end of 2024 will be used ROS packages. So if you know what is ROS, you can easily get into the market. So how it started? So we can discuss what is the history of the ROS. So there were two researchers in the Stanford Artificial Lab, named as Eric and Karen. They noticed that most of the researchers spend most of the time to reinventing the wheel. What does that mean? That a researcher do some research and then publish some articles, and the next researchers read that article and think that it is not able to, and the new researchers think that it is not possible to start from that area. So that the new researchers read the article which already published, then it tried to run the same code, but it does not work, because when the because that system work on different system configuration, the different libraries they use. So that researchers again build the same system which already built, and then do some new research. So the ratio of the new research compared to the reinventing the wheel was quite low. So they target that, they address those issues, and then they proposed a ROS, which is robot operating system. So as you heard, that robot operating system is not an actual operating system. It is a middleware between the operating system and the tools. So it provides some such tools for the robot applications that the new researchers or anyone can reuse the reuse the already built packages and then do research. So ROS is basically is a combination of four main things, which is plumbing, tools, capabilities, and ecosystem. So what does it mean, plumbing? So it plumbing means that we have make multiple softwares on multiple package and they run simultaneously. So you can just call those nodes, and those nodes are linked by the topics, and the messages are summarized and published by the means of the messages. So suppose here you can see that the, the square box represent the nodes. So then one node is linked by the other node by the means of topic. So this closed loop of communication help the robot system to communicate each other. After that, it provides a tool. Suppose you want to make a robot, but you don't want to spend a huge amount of huge amount of money on robot system. So first, what you can do, you just make a robot in simulation environment. You just check the feasibility of the robot. You provide some data, and you can see how it works in the real world. Wait a second. My slides are visual. Sorry for the inconvenience. There's some system error. Now my slides are changing. Slides are changing.
I guess there's some internet issue, so you people can identify and send the message in the.
Not working. It's not working. No, it's not working. Slides are not changing.
Sorry for the inconvenience. Actually, we are having some technical problem. We are trying to resolve it. I guess you people were unable to visualize the slides changing, so we are trying to fix that. Thank you for your consideration.
Window. नहीं,
चलो स्क्रीन पूरी शेयर कर सकते हैं अपने विंडो वो करके देख सकते हैं मैंने कहा ऐसे
विंडो ही कर लेते हैं, कर लेते हैं।
So in the meanwhile, our trainer is trying to resolve the problem. I'll like to talk to you through the agenda of the day. So once we are done with the basics and introduction to the ROS, I am going to talk to you about how we are utilizing ROS in our lab and how we are using ROS in developing some of our very cool projects. So we are working on autonomous vehicle project, we are working on agricultural robotics projects, and we are going to talk to you through how we are utilizing ROS in whole of the whole infrastructure of these robotics application. So as you might know, that self-driving car is a very complex robotics problem. So this is a very good example that we are actually excited to share with you, that how we are incorporating some of very high-tech cameras and how we are using. So today we have planned actually a live demo of some Intel RealSense cameras and how it is being utilized in the infrastructure, how it is actually publishing and doing all the technical things that are actually the fascinating power of ROS, and we are going to exhibit it in real time. So let's, I guess the problem is resolved. Let's go back to Mudassir. And towards the end, I will take back, I'll come back and share some things. Over to you, Mudassir.
Thank you, Shmela. So we are discussing what is ROS. So basically, ROS is as it is named, it suggests a robot operating system, but it's not an actual operating system as Windows or Linux. It's a middleware between a operating system and the tools. So ROS is combined of four main parts, which is plumbing, tools, capability, and ecosystem. What does it mean, plumbing? So it means that if you have multiple programs running together, you can communicate each of one each of one with the means of topics. So each node is combined with other node by the means of the topic, and the message and the communications be placed between the nodes are by the help of the messages. So this is the uh, structure of the plumbing. So what is the second is the tool. Suppose you want to make a robot from scratch, you just buy the components and just build it, and then you realize that working it is not working fine. So it will waste your money. So what the ROS provides is a simulation environment, a gazebo, You can build a robot in the simulation environment and test its feasibility, how it works in the real environment. You just provide some data and then see the data in the real world and see how it will work in the real data. So in the tool, it provides simulation environment, which is Gazebo software. And for the visualization for the such a graph and other things, how the camera work, you have two main softwares available by the ROS, which is RQT and the ROS. Other than that, it also provides the capabilities such as mapping, controlling. What does it mean? That some researchers build a capability in the robot, such as they build a robot for navigation and then tested it, and then they implement it in the real robot, and then they publish the codes in the open source. Oh, and they publish the codes open source. So what the other researchers do, they just copy those packages and implement on this other robot, and it will work fine. So this is the meaning of the capabilities. So there are multiple capabilities available by the ROS, such as control, planning, perception, mapping, and manipulation. And other than that, the ecosystem. What does it mean? That is a huge community of the ROS robot operating system. They are contributing daily, and so the other researchers or other students and other R&D engineers can take some help from the published work. So why ROS? What is the importance of the ROS? As you can see that in the previous time, most of the researchers reinventing the wheel, and they spend much time, and they spend less time for the new research. So ROS provides such tools and packages so that it save times to it save time, and so the new research will occur. And also it provides CLI tool, which is compound line tools, which help to deploy and monitoring and debugging the software. Suppose you want, it's the same thing if you just make a robot in simulation environment and test its feasibility. And also the main thing that the ROS provides is the hardware platform. So you can use any hardware controller with the ROS, such as Arduino, Raspberry Pi, Odoo, Jetson Nano, and any hardware microcontroller, and you can install the ROS on it and implement the code on it. So what's the philosophy behind the ROS? So it is a peer-to-peer communication. It means that you have multiple programs running in your computer, and you just combine all of them and to make one loop. So it provides that communication power. And also, what is the distribution? It means that if you want to combine multiple computers together and you want to link all of them, you just run the code in each system and then combine together. And the other thing that it's multilingual. What does it mean? If you want to code in Java, you can do it. If you know how to code in C++, you can do it. So it provides a diversity on the language barrier. So it doesn't uh, resist you to learn any particular language. There are multiple language which ROS can tackle. And also it's very lightweight. It means that you can easily run on any system which and any robot. And also it is an open source software. It means that you don't need to spend much money to buy the system and then do it. It's just open source, and a huge community is there to help you. So what is ROT? We just in a layman definition, a robot is a combination of three parts, which is sensors, actuators, and control. Multiple sensors are attached in a robot. What sensor are attached in a robot? What is it help? It just it sense the environment and tell the and get send the information to the actuator, and the actuator will will run on it. And you have a control system, which application, how you want to sense the environment and what you want to do with the actuators. So this is the basic definition of robot: a system which contains a sets of sensors, actuators, and a control phenomenon. So how it helps in ROS? So as I told you that in ROS, the communication it happens with the publisher and subscriber. You want so it means that the sensor sense the environment and publish the data to the topics, and the topic receive the data and then send that data to the actuator, and actuator subscribe the topic, and those communication happen within the nodes. So we can see that a basic example where we just make a robot. Here we have sensor, actuator, and the control mechanism. So we have sensor as a ultrasonic sensor. It senses the distance, but it sense the distance, and the actuator, which is a stepper motor. So what is it? We make a robot where we just throw a ball, which is throw a ball, and the ultrasonic sensors sense the distance, and then give the information to the actuator to slap a ball. So it's a small demo how it works. So here, if you have noticed that you have actuator and a sensor, but one main thing is missing, which is control. How you control this mechanism? So here it provides the control mechanism. It sends the environment, means from the sensor. It publishes the data to the actuator, and the actuator perform the action by subscribing the topic, and it will work in a while loop. So how it ROS help? You can also do it in the Arduino as a simple bit, but how it you can do it in ROS. So as I told you that the means of communication is between the subscriber and the publisher. And you make a node. So a node is a main thing, and the topics are linked with the nodes. So the ROS provides its own long system that string together modules, and don't need. Suppose you want to make a robot, and you don't want to write a code for the ultrasonic sensor. So what you can do, you just go to the open source their packages, ROS packages. You just find out that there are some packages available for the ultrasonic sensor. You just copy it and then implement on your robot. So it helps you to save the time to don't write anything for the ultrasonic sensor. So this is in this way the ROS helps you to save the time, and then you save the time.
Um, in the chat, I can see a message. Savera Yasin is asking, when will the presentation start? I need to ask that, is presentation visible to everyone? Because Savera, we have, the presentation is already started. We are almost a quarter way through it. I will be waiting for the response. I just need to make sure that everyone can see the slides. Can anyone else please respond that if the slides are visible to them? Okay, I guess, Savera, there is some technical issue at your end, because Mohammed Muzammil is commenting that he can see. Okay, other people can also see. So I am not sure how I can help you. Maybe you should try leaving the meeting and rejoin it. Then perhaps you would be able to see it. Okay, let's continue with it, and we will be waiting for you, Savera. Thank you.
Shall I start? So here you can see that how it helps here saves the time. So we are discussing that if you want to build a robot from scratch, and if you don't want to write a code for the ultrasonic sensor, you just go to their website, ROS packages. You just copy the package for the ultrasonic sensor and then use it on your system. So it will work on your system also. So in this way, ROS helps to save the time. And what the other thing that the ROS provides some visualization tool, and so you can see how the system works in real time. So, and also other than that, ROS also provides some tools so to save your data, and you can play or you can record the data and for the future purposes. So it helps to visualize the data in a real time also. So with ROS, there are three main other software will also install on it, which is Gazebo, which is simulation environment. Suppose you make a robot in a simulation environment and you test how it works in the real environment. So you make a robot, you just give the instruction to the robot to perform. Suppose you want to do autonomous navigation. So what can you can do? You just import the robot in the Gazebo simulator, and you just write code on C++, Java, MATLAB, or Python, any in any language, and you just see how it works in the simulation environment. And in RQT, which is a visualization tool, you can see how the how it works. Means you want to import the robot in the Gazebo environment and see that you want to you want to modify some of the sensor. If you want to tune the parameters of the any sensor, you can easily do with the RQT and see at which settings the robot will find. So in this way, you most of the money and it saves your time, money, and everything. And other thing that you can also visualize how the robot which will work in the real environment. So it provides also visualization too. So if you want to so in this way, the gazebo helps you to make a robot from scratch, and also provides ROS provides a stacking. What does it mean? You have to make so there are multiple stacking packages available on the ROS for the different application. Here, this is the navigation stack. What does it mean? Means that the researchers make a node and then stack together to form a particular step. So in this way, if you want to implement your autonomous navigation in your robot, you don't want to write anything. You, you don't want to write anything. You just import the package from the ROS community, and then you can just modify on it. So here you can see that the different nodes are already built, which is global planner, global cost map, and they all are linked with the topics, and those topics are linked with other stacks, which is map server, sensor source. You just only call that stack. You don't need to write anything in it. So it helps. So in this way, OS helps you to save time, and also you don't need to write anything again and again. And so uh, this is one of the stack which is available on the ROS. There are multiple stack also available on the ROS, and also you can also make your own stack. What you can do, you just make some nodes. Means you make some codes, and then you combine together to make a one stack. So in this way, the other researchers or other students can easily get your stack and then implement their own research on it and do research on it. So what is also now we talk about the gazebo simulation environment. But if you want to implement in the real environment, what you can do, you want a microcontroller. I mean, what is a microcontroller? Is a brain of the robot. So you want a robot to work in a real environment. So you just take a controller, and then you just easily communicate with the controller using a library ROS Hero. So ROS Hero is available in every microcontroller, which is Arduino, which is the Raspberry Pi, Jetson Nano, and any robot. So you make a code in the some. And other thing that what ROS provides means if you test the robot in simulation environment, you can easily copy the same code and same packages on the real robot. You don't need to modify anything. So it will work fine as it works on the simulation environment. So this is the benefit of the ROS. As I told you, there is a huge community of ROS present worldwide, which are contributing daily. So there are three main websites which are hosted by the ROS, which is WikiROS. And in WikiROS, you can find all the packages and all the documentation. This is the official website. And in what Discourse or ROS organization, it is an organization where if you are stuck somewhere, means you get any error, you want to solve such error, you just go to those websites. You just write your problem, and you can get an answer from the expert. So in this way, this communication helps the researcher to in this way the researchers can easily communicate with each other, and they discuss their problem and they get the solution. So this is a huge community. And and you will get your answer easily. So the ROS was basically established in 2007, but it takes 3 years to make a distribution. So the first distribution was online was on 2010, and after that there are around 13 versions already embarked by the ROS, and the new one is the new tick, which is released a few months before, and now it is in the testing phase. And now the stable one is the Melodic Mariner. So we will use Melodic in our course. You can also use other ROS distribution if you want to use, but now the Melodic is not stable, and there are multiple packages available on the internet, so you can work on it. And also we will use a Melodic on our workshop. So these are some of the biggest companies that are using ROS worldwide, which is ClearPath, PAL, Eugene Robotics. So now they are officially using ROS in their robots. So if you learned how the ROS works, you can easily get into their market. And nowadays, the robotic and software companies and the universities once a student must know what is ROS. So if you don't know how the ROS works, you cannot get into the market. So now this is the main requirement for the robotic engineer or the scholar and R&D engineer. So these are some top 10 robotic companies that are officially using ROS on their robots. And other than that, there are some multiple companies or the universities are using ROS as their ROS on their robots. Here you can see the big names on. Here you can see some big names that are using ROS. And so if you know how the ROS works, you can easily get into any of these companies. And here you can see some of these robots, which is Rover and Viper. They are built by the NASA. So all these two main robots which are built by the NASA, Rover and Viper. So NASA is now continuously spending much money on the on the challenges how they are facing on the Mars and everything. So what they did is they just make some challenge. They make an online, and then they want researchers or the students wants to contribute on their robot. So they multi. So the NASA, what NASA did, NASA make ROS packages and they publish online. So and they make a competition on it. Suppose you you want to make us you want to contribute their robot, so you can just go to their challenge. You just take a part, and if your code works fine, they can also pay you. So this is the benefit of the ROS. Some big companies are spending millions of money on it, so that they get the better solution for the better future. So this is the ROS robot robot which already on the Mars, and this is the Viper. They are launching in the by 2 years later. They are planning to launch Viper on the moon, so that they can see the volatile things on the moon. So if you learn the ROS, you will also get. This will teach you so many things about robotics, and also it will save your time, and it will give you a good skills to learn it. So what we are planning to do. So we just make a curriculum. So we started with the basic, and then we go to the not advanced level, but the beginner level. So other than that, we not only give the knowledge of the ROS, but we also give the knowledge about the Linux, because most of the students or the don't know how it works, how the Linux works. So other than that, we don't teach only ROS. We also teach about the Linux, the basic of Linux, how it works, and what is command line tools and CLI and everything. And also if we will use Python as a programming language, so we can also a basic of the Python. So those who don't know how the Linux works, how the Python works, don't worry, we can handle on it, and we can teach you the basic on it, so you can easily grab the things. And the curriculum is set is such a way that you can get all the basic things about the ROS. It includes the hardware, it includes the image processing and everything. So it's a good course for those who wants to pursue their career in the robotics and who wants to learn what is how ROS works and how it has in the future. So those who already joined this workshop, we, they can easily get some benefit on it. And those who are thinking, let's just go and then just go and and take a part in this robot operating system workshop. Uh, Thank you. Now I will ask Maila to take over.
Am I audible? Am I audible?
Yes.
Okay. Okay. Assalamu alaikum. This is Asin Rahman. Okay. Thank you. Yeah. So this is Asin Rahman, Research Associate at Smart City Lab. I'm actually organizing this webinar. So what I have observed so far that the communication is one way. So I would like to have the candidates giving their feedback so far about the presentation, about the webinar, about the content. If you have any questions, if you have any feedback, you can share, you can tell us. And I would like to know about your background, all of the candidates from where you are you a student, are you a professional? So will it be possible for everyone to share their brief introduction? You can just open your mic one by one, and I'm going to tell you your name. Then you can open your mic. You can give your brief introduction. Then you can give a feedback, a brief feedback on the content if you have faced any problem regarding the communication or anything. Okay. So let's start with Mr. Okay, let me see who we have here. Okay, there is Mr. Abdul Muttalib Khan. Can you hear me? Hello. Okay. I hope I'm audible and you can hear me. I guess there is some problem at all of your end from communicating. I can't see anyone's mic open. Okay, Miss Neha is here. Yes, Neha, please speak. You can speak. Hello. I can't hear you. Is there anyone else? Okay, let me ask. You can use your mic, right? You can open your mic. Okay, right. Okay. I think mic. Okay, I'm checking. Thanks. Okay, you can text as well if you wish to. I think Mr. Muhammad Ali has replied with yes. Ali, can you open your mic? I don't understand this. If you guys have any feedback up till now, if you wish to say anything, you can also send a text in inbox. I guess there is some problem from your end in communication. Okay. Thank you, Ali. Yeah. Okay. Carbon text. Can you open your mic, or do you have any problem in opening your mic?
Hello?
I would like to
Hello?
hear you.
Can you hear me?
Yes, I can hear you.
Okay. Sorry, my name's not Carbon.
Yeah, I can
I tried
understand,
changing
but
it. Yeah.
you can tell your name.
Yeah,
You
I
can
tried
give your
changing it.
brief introduction.
Yeah, so my name's Taha. I'm in Japan right now.
Okay. Welcome,
Yes,
Tom.
I was also part of the neuro computation lab until 2020, last year. So I just recently started using ROS, and
Okay.
I've been running into a few problems, and I was wondering if you could answer like some questions.
Yeah, sure. I think
Yeah,
you must ask, and I think the teachers are going to note down your question and they are going to then answer them. Please ask.
Yeah, so the first one is the presenter, Mr. Mudassir. He said that ROS can also run on Java.
Okay.
I I'm pretty good at Java, so I was trying to use ROS with Java, but I think maybe I'm mistaken. I could be mistaken, so please do let me know if I'm mistaken. ROS doesn't let you work with Java, the newer version. It's you have to go to very old versions to use Java.
Okay.
So I was just wondering if I'm in the wrong or if this is true. Like I'm not
Right,
looking
right.
at the documentation correctly. And the
Okay.
second is,
Yeah.
so if I do work on an older version of Java, on an older version of ROS, can
Yeah,
I
yeah.
then also write code in a new version of ROS on a different system and can both communicate, or does everything have to be on the same version of ROS?
Okay. Okay.
And
All right. I
and
think I should ask Mudassir to answer the question. Mudassir, would you like to comment on it? Yeah, please. Okay. And I'm handing over to
and the
Mudassir. Yeah,
third
sure.
question is,
Please. Please,
yeah, the
please.
third question is ROS 2. Like
Yes.
learning, should I learn ROS 2 or should I concentrate on ROS, like the first one? And can
Okay.
both communicate, or like what's the deal with both?
Yeah, I think you are actually asking about the synchronization of both the systems if they can run simultaneously or not. Maybe what's the method of engaging both of them together. I think but Mudassir
Yeah, yeah,
can
yeah.
answer in more detail. Okay. Okay,
Thank you.
Mudassir, you can answer.
Okay, so Taha, yes, you can use Java for the ROS. There are some libraries, ROS Java. So what you can do, just include those libraries on your Java code, and then it will link with the ROS. And your second question, that if you make a code for different distribution, means you make a you want to run a robot in the monolithic and you make a code for the neotic, no, it will not work. You have to make on the same page, means on same distribution, you have to make a code for the same distribution. And for your third question, which is about ROS2, so basically ROS2 is not in a testing phase. You cannot find multiple packages on it, and especially with the Java, because Java is not so many researchers are nowadays using, because most of the researchers and the companies use Python nowadays as a programming language. So you can find multiple packages on the Python programming, but not Java. So if you want to learn, if you want to code in Java, so you just must stick on the ROS one. And if you know how to code in Python programming on C++, then you shall start with the ROS 2, because ROS 2 now is in the testing phase. Not it's not stable as ROS 1.
Can I use ROS 2 with ROS 1, like on different systems, or like will they be able to communicate with one another, or should I just stick to one?
No, no, it will not work. You have to make on the same. If you either ROS 1 or ROS 2, because their mode, their structure are totally different. ROS 1 structure and ROS 2 communication structure is different, so it will not link together.
Okay, right. So just one last sort of a favor. Can you send in the chat the link for the Java libraries that you mentioned?
You can search
I'll just look at the
ROS Java.
documentation.
Yeah, you can
Yeah,
search
ROS
ROS
Java.
Java.
Yeah, I've got it open right now, and it just
Mhm.
says it's valid for kinetic, not for
Yeah,
melodic or noetic. Yeah. So
no, it will.
how would I use? Yes.
Yeah,
How would I
because
use Java and noetic?
no, you cannot use what I told you, that now most of the researchers and the students use Python or C++ as programming language. So you can find many
Right.
packages of documentation on it. But for Java, I think they are not make publish for melodic and neotic. So you have to stick on the kinetic, cross kinetic.
Right. Okay. Okay. Thank you. Thank you very much.
Welcome.
I understand. Thank you.
Okay. Thank you, Taha. Thank you for your questions. I can see there is Mr. Muhammad Ali, who was asking about the syllabus details. Muhammad Ali, is it possible for you to come on mic and maybe you can give your introduction and then you can have your questions, if you can hear me? Okay. I think if you are not available, then I'm going to ask the teachers if they can share the slides and share the material. And thanks for your positive feedback. Okay. Mm, There's Neha Mazhar, Sami Salim, and Savera Ansari. Is anyone of you available to give your feedback about the session and maybe briefly just introduce yourself? I'm waiting for your response. Hello. Okay. Okay, think I'm going to ask Mudassir to share the syllabus details if we have some for the future course as well.
I
Could you
already,
hear?
I already just shared it.
Okay. No, on the screen. Can you share on the screen?
I already
This
shared.
is the one. No, details of the whole course. Okay. So the people who are asking for the syllabus details, they can see the details on the screen right now. There's outline. There are the topics and activities which will be going through the classes. So you can look at the course details and you can ask questions. Then after, okay, somebody's saying it's not visible. I think we need to zoom it. It's not visible for them. Give it. Please give us 5 minutes. We are going to show it. Okay, Mr. Ali, is it visible now? Okay, so you can all see the course outline and you can ask if you have any queries about the outline or about the rhythm, how we are going to go with it. Okay. I think the lectures are divided in 8 weeks and you can see the activities and the topics that will be covered in 8 weeks. Okay. Yes, of course, Mr. Ali, this will happen online and uh, due to lockdown, in Karachi, we cannot conduct classes live in the campus. So all the course materials and all the activities will be online. Okay. Okay, Mr. Fazan, I think our finances are being taken care by Mr. Uday Javed and Mr. Shahrukh Salim from CERT. So they can answer about the fees structure and about the finances details, how the fees can be paid. I cannot answer about these. I can answer about the technical details and I can answer about the course material and about the teachers. So if you have any question about that. Yes. Fine. Okay, the fees is mentioned in the brochure, but the brochure is not visible right now. Melissa. Can you show it again? Okay, Melissa is going to present the brochure. You can see the fees there. The fees is mentioned there. I think on the left corner, it's 6,000 Pakistani rupees. Okay. Okay, Mr. Ali, our lab is situated in Karachi, Gulshan Iqbal. We are actually in NID University. Okay. As Shamala mentioned earlier, this is a Smart City Lab National Center of AI, and this lab is situated in NID University. Yes, exactly, NID University. And we are a part of a big consortium. There are 9 labs in the whole Pakistan, and we are one of them. So we are working on the projects related to Smart City, as the name emphasizes. Okay, I think we are done with the question answer session for now, and we are going to give the control to Shamala, and she's going to present the remaining of the lecture. If you have any questions, you can ask in the middle. You can raise your hands, and then you can ask the questions. You can leave text messages in the inbox. I'll be available, Mudassir is available, Mr. Mala is available, and we would love to answer all your questions and resolve all your queries. Thank you so much. I'm going to give control to Shamala. Okay, thank you.
Thank you, Essen. Thank you for the question answer session. I hope everyone just clarified whatever queries they were trying to they were having. There's some other message. Please try to share the syllabus browser on my email. Certainly, Muhammad Ali, we will get back to you on your email and we will share it. Um, all right. So moving on with the session, as I said that towards the end of the session, I will be showing you some of the utilities of ROS that we are making over here at Smart City Lab. So very quickly, I'm going to show you, I'm going to tell you about one very interesting application that we have. So as I mentioned in the beginning, that here at Smart City Lab, we are working on sensor technology, incorporating different sort of mapping modules, and we are making utility of those mapping modules aimed towards self-driving vehicle. So as you all know, that self-driving vehicle is a very complex, as I mentioned it in the earlier talk, that it is a very complex robotics problem. It requires many different modules working together in conjunction to produce a very robust and low latency environment. So as I mentioned that we are using and making utility of robot operating system to address this problem. And very quickly I'm going to show you and then along the way I'm going to talk to you about the sensor itself and how we are doing everything. Right now I will request Essen to just show you our little setup, and then I'm going to show you if it is, please let me know if it is visible to you all. If you can please focus on the setup. So we over here, I'll talk you through the setup. We have uh, Intel RealSense camera. So we have an Intel RealSense camera. As you can see, this one. So this is a very sophisticated RGBD camera. When I say RGBD, I mean that it is an RGB camera, contains red, blue, and green channels. And in addition to that, it has a D channel, and the D channel provides you with the depth information. So it is a depth camera in a very simple word. So these depth cameras actually provide us the information of the environment in not only x y coordinates but also the z coordinate. For a given pixel, it will tell you that where is that specific pixel lying inside a 3D coordinate position. So this is a sensor, and as any robotics application, we need to incorporate many different sensors, not only one, but multiple. And we need to, okay, nothing is visible. Okay, if nothing is visible, then what I should do is try some, I want you all to see this. So let me just take a pause and I'm going to ensure that it is visible to you. Okay. So is it visible now? Muhammad Ali, is it visible now? Don't present. What you can do is you can, in the chats menu, you can pin Dr. Mohammed Khurram's. If we are sharing. Okay, yes, it is now. Okay, I got the cue. I got another question by Abdul Muttalib Khan, that do you use LiDARs? This is deviating from the point a little bit, but of course, this is one interesting topic that I always want to comment on. We will be using LiDAR. We have whole infrastructure of utilizing the Velodyne Alpha Prime LiDAR in our autonomous vehicle. But on a very personal note, I think that LiDARs are a redundant sensor for autonomous vehicle application. Why is that so? Because you might, if you are asking LiDAR about LiDAR, you might be aware of the philosophy of Tesla. According to Tesla, LiDARs are redundant and useless for a self driving vehicle. They try to emphasize on the fact that if humans can drive a vehicle with two of their eyes, then a very nominal stereo system should be capable of driving the vehicle um, as good as a human. So, to achieve a human level accuracy, it is not essential to have a what should I say, a lidar on board. But then again, I'm just going to give another statement to contradict my statement that we believe that we are uh, developing in world. The autonomous driving community believes that developing a complete autonomous vehicle is going to resolve the problem of human error in driving, in normal driving. The accidents occur due to human error. So, if we want a machine to perform par human capabilities or par human intelligence, then we need to provide it with the information that is par human comprehension. So, that is where the community, this is the statement that the community uses, the community which supports LiDAR uses. So, I guess it is it can be only because we are a research lab and we do not negate on how on which technologies should be opted. We actually work on addressing the problems. So we are actually going to incorporate and study both of the sensors in detail. In maybe sometimes in our future sessions, we will be showing a comparative study between a stereo system and a LiDAR system, and we would be going in that way forward. So, and there are many things to be explored. LiDAR, in short, to answer you, do you use LiDAR? Yes. Do you use LiDAR in present? No. Will we be using it? Yes. We are going to use the Alpha Prime LiDAR of Velodyne, and we will be sharing with you the journey that we are having. So that was a little off the rails of the agenda discussion. If anyone wants to go ahead with the and ask any questions on the topic, I will be very happy to answer. Okay, I'm seeing some questions. Can we work with you? Uh, Oh, of course. We do offer internships to uh, good students, and especially at the end of this robotics course, we will be offering internships. Actually, we will be having a whole capstone project, and the students who will be successfully completing their capstone projects, they will be offered an internship to work exactly on this autonomous vehicle project, or maybe on the agribot project. Right now I just talked a very a small fraction, talked you through a very small fraction of our autonomous vehicle project. What I'm going to do in a while is talk you through the agribot project also. So um, okay. Yeah, Abdul Muttalib, you have a question. I'd like to take it. Go ahead, please. If
Hello,
you want to
Assalamu
open your
alaikum.
mic, you can. If you want to write it down, you can.
Hello, Assalamu alaikum.
I
Hello,
cannot hear you, Abdul Muttalib. Walaikum assalam.
Hello? 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 Ma'am, can you hear me? Hello? Hello?
Yes, what is your
Um,
question?
okay, you can hear
Sir,
me.
I have a question
I
related to the
cannot hear
camera
you, Abdul
you have
Muttalib,
used in your
but
robot.
I can hear. I can see you speaking.
Uh, can you hear me?
Okay. You're asking about the camera. There must be some issue on my side, so I'm going to take my your question from my colleague.
Yes. Uh, I have a question related to camera and whether
Yes.
it.
What's your
My
question?
question is that is the camera works in night condition, like where there is less light visibility. So
Yes. Yeah, it will work on the low light and daylight in night, or it uses two cameras and the depth information. So it will work on night also. In the low visibility area, it will work.
okay,
Okay, so the camera has a rather not very robust nighttime capabilities, but it is powered by IR cameras. So as you might know, that the IP cameras or the surveillance cameras, which have night vision capabilities, are powered with uh, IR sensors. So we have an onboard IR sensor on the Intel RealSense D435i, which is the model of this sensor, and it can operate under certain limited capabilities at night time.
ma'am,
Since the sensor is since it
can
is a very raw sensor, and we can access the okay I okay, you're saying something. Am I audible? Okay, what I'm going to do is I'm going to I am sending a link to the data sheet of this sensor. Actually, I like to call it a sensor because we have much more capabilities and much more root level access to the hardware of this sensor rather than a simple camera. So this is a sensor in which we can modify, calibrate according to our needs, and that is why I'm calling it a sensor. I have shared the data sheet, and I hope, Abdul Muttalib, I have answered you. Um, okay, there was some other question. If we don't have enough knowledge, can we still learn this course? This course, Fazan Ahmed Khan, has been curated to accelerate the knowledge of a very no voice learner. The only prerequisite that we are actually that we want you to have is the will to learn. That's the only prerequisite. If you are willing to educate yourself, then there is absolutely no hurdle that you are going to face with this course. So I believe you will be successfully able to complete this course and learn and take away many things from it. Okay, so coming back to the topic, this sensor is being utilized to create the mapping module of autonomous vehicle. So I will very briefly talk about what is the mapping module of an autonomous vehicle. An autonomous vehicle is supposed to navigate. Okay, what? Yeah, I guess I'm going to the setup you have seen. There's the camera is mounted on a tripod, and I'm going to move it around and show you how it is mapping an indoor environment. I guess I'm going to close this video, and I'll talk about the mapping module and then I'll show you the output in ROS. So I'm going to present my screen. Please let me know if it is visible. Okay, so I guess the screen is visible. I will open this. Move this camera around and leave it at a very static place. And now I'm going to talk to you about why we are using this camera and what is it and where does it lie in the infrastructure of an autonomous vehicle. As I mentioned earlier, this camera is being used in the mapping module of autonomous vehicle. So, a mapping module is a very essential module for an autonomous vehicle. In an autonomous vehicle, um, it is a requirement of autonomous vehicle to be aware of its environment. So the process, the technical term associated with it is called as environmental cognition. So we create a cognitive behavior and we provide the vehicle with the capability to understand where it is standing in the world on basis of few values which are coming from different sensors. The sensors are some mapping modules and the modules which can take input from uh, the environment in terms of image, in terms of distance information, and create a digital twin of the environment. In addition to that, there are different sensors like um, positioning sensors, like the RTK sensors. In when I say positioning sensors, I mean GPS or GNSS systems. When I say the RTK, I mean that the real-time kinematic sensors. Um, so these all contribute in help a vehicle to identify that where it is residing inside the world coordinates. So these all sensors work in conjunction and create an environmental perception for the vehicle. Once it has a clear perception of its environments and the modules and the other dynamic and non dynamic elements present in its environment, what it does is this information is further passed on to another module, which is called as the behavior planning module or the motion planning module. So these modules are responsible for taking the actuation decisions. When I say actuation decision, it means that they are on basis of the information that a map has generated. A map will be telling that which points in its vicinity are occupied and which points in its vicinity are actuatable. So on basis of these information, it is going to take the decision to move forward and actuate and drive towards its destination position. So all these are, as I mentioned, all these are because of the backbone, which is the mapping module, and the mapping module that I'm going to show you is Intel RealSense camera. And the Intel RealSense camera, as you can see in front of yourself, is actually creating a map using uh, ROS. So this is the main reason of telling you this whole story was how ROS is contributing in creation of self-driving cars or self-driving vehicles throughout the world. So what I have now, I'm going to talk you through what I have in front of me is a graphical user interface of RTab map. What is an RTab map and what does it have to do with ROS? RTab map is a visualization tool, and by using RTab map, we can create different 3D maps. We can utilize the sensor informations. We can see what sensor information or what the vehicle is seeing, and we can help the vehicle make sense out of that raw information. So on my top left corner, you can see, I hope the screen is visible. Um, is the screen visible to everyone? Okay, so on my top left corner, I have this RGB value coming from the sensor. So the RGB value is simply the red, green, blue camera values which is coming incoming from the sensor. On my bottom left, it is um, on my bottom left, it is showing the points and the features that it is identifying in the environment. So what are the features? Now we are coming to the sensor core raw values. These are the values that a sensor utilizes to the uh, identify its environment. So these are similar to the points or point cloud that is being generated by a LiDAR. So for each pixel value, the sensor is returning a distance value in a 3D space, and we are utilizing RTAP map, which is which is a library of ROS, and we are using it to grab the sensor values. And right now we are just mapping those sensor values in a heat map sort of positioning. The furthest points are the blue ones, green and yellow ones are something in between, and the red ones that you can see are the objects that are residing very near to the sensor. So this heat map actually is identifying uh, the depth of whole image screen. So moving forward, I'll tell you that on top right corner, you can see the occupancy grid. Uh, Occupancy grid is another feature that we can utilize in ROS, and we can create a two-dimensional map of our environment. The utility of this occupancy grid is very high in autonomous vehicle applications. Um, I will share with you that so a vehicle does not always move using a three-dimensional map. Most of the time, when an autonomous vehicle is moving, it uses a two-dimensional map to actuate, and that's where the occupancy grid comes in. So the occupancy grid is a map of all the static objects in the environment surrounding the vehicle. Um, Depth cameras and LiDARs are prominently used to construct the occupancy grid of map. A set of filters is first applied to the depth camera um, data to make it a usable occupancy grid. For example, it identifies the drivable surface points. So as you can see in this map, this gray map, if it is not making sense to you, I will explain it. That these light gray regions, it is telling that these are the traversable regions. And the black regions are the ones which are somewhat occulted. It cannot see or identify that what it is. If I move the sensor, then it is going to remap those points, and it is going to re-identify whatever it is seeing, and it is going to create and readjust the occupancy grid. I'm slowly moving my camera. You can see Mudassir over there. You can say hi to him. So this is how we are creating a 2D occupancy grid, sorry. So in an occupancy grid, there is no information about a dynamic object. So you might have seen that on this very black screen, which is in middle of um, top left and top bottom, the middle one, there was some visuals coming and going of the dynamic objects. these visuals were actually being utilized to identify the dynamic nature of the environment, and the values were being used to eliminate those dynamic elements from the map. So that is how we actually create a 2D environment for a 2D static environment for a vehicle. So why does a vehicle need a 2D static environment? Um, it should always know. Let's talk about a scenario. There's a vehicle which is going on a very straight road, and there's another vehicle which is on its right or left or front, wherever. And if on day one I'm traveling from point A to B on a straight road, that vehicle is beside me, it's traveling, and I'm creating a map of my environment, that dynamic vehicle is going to reside in that place, is going to move along that place. But on next day when I'll be driving from point A to B, the whole environment is going to be the same, but that vehicle is not going to be there. So that discrepancy or that conflict is going to create an ambiguity for the vehicle, for the autonomous vehicle. So that is why when it is actuating, it actually eliminates the dynamic modules of an environment and creates a static map. So the static map is actually the utility which actually helps create an environment and help uh, the vehicle re-identify the environment. We don't need the vehicle to identify an environment once. We want it to identify the environment whenever it is going to move through it or actuate through it. So this is a very small and when I said this is a whole discussion about the occupancy grid. This occupancy grid can simply be created using ROS by launching one node. So this is the beauty of ROS. This is the beauty of RTAB map, that it does not need a complete launch file. As you will move forward studying about ROS, you will familiarize yourself with the concept of launch files and nodes. These are some technical ROS specific terminologies that I have used. I am going to use more of them, but I do not expect that everyone would understand them at this point. But I'm certain that towards the end of the course, you would be very fluent with these terminologies and very comfortable using these terminologies and using these concepts in your personal applications. So, as I mentioned, that I emphasized on the essentiality of the occupancy grid, and then I mentioned that it only takes a very few nodes to execute and create this occupancy grid using just the sensor value that we have. Uh, okay, and now the highlight of the mapping module, as you can see that this sensor creates a 3D point cloud, a three-dimensional view, a three-dimensional um, uh, perception of its environment. So this three-dimensional perception of the environment is the most important part for a vehicle to actuate dynamically, actuate in a dynamic environment. So this help to create the person to this helps the vehicle to take decisions, very small decisions like lane keeping, lane changing, and very big decisions like which road to take, or which what should I say, which path to follow. So, for any given destination, let's say you want to travel from Karachi to Lahore, there would be different highways that you can take. So, the vehicle should be you are not going to tell the vehicle which path to take. The vehicle should be self sufficient to when sufficient that when it is given a destination point, it should identify on basis of various inputs, various runtime parameters, that what path it is going to take and where it is going to which roads it is going to follow. So this 3D map helps that vehicle to actually genuinely create that map and uh, remember it for the next time. So as you can see, In this activity, I'm showing you the creation of map using the IntelliRealSense camera in an indoor environment. Of course, I'm not outdoors right now, so I'm not showing you any outdoor utility of the sensor. But it's the map creation process is exactly the same. The scripts that will be utilized are going to be exactly the same. So this is what we do to create a map, and this map is, as I mentioned, the self-driving vehicle consists of different modules. Each module need to perform its specific tasks. The modules would start from hardware modules, which are basically the sensor modules. Uh, and ROS is going to play its role in each of the specific modules. When we have attached different sensors to a vehicle, ROS is going to help acquire the data from each individual sensor, synchronize those values, and help and pass it on to the filtering modules. Then is the filtering module of the vehicle. Filtering module actually filters the data and help clean the sensor raw data, because whenever we are taking input from an environment, especially from our real world environment, it's going to have noise, it's going to have bad values. So ROS again provides many libraries. Just to name a few, we have filtering libraries like Kalman filtering, EKF, extended Kalman filtering. We have UKF, uncentered Kalman filtering. We have Madwick filters for GPS values. We have IMU filters. We have Mahoney filters. So we utilized all these libraries, and utilizing these libraries is just like, if you are familiar with any hardware platform or software platform, you just import a library and you utilize it. You pass your values in that, and it just filters out the values and gives you a clean data. It's as simple as that, and we are going to walk through that in our course. So then comes, after the filtered data, then comes the perception module using the raw information from the environment. The mapping modules create different levels of maps: the 3D maps, the 2D maps, the road maps, the HD maps, online maps, offline maps, and it makes many different maps and uses conjunction of those maps and passes these values further. This is the perception module. It passes these values to the motion planning module. So when the environment perception module or environment mapping module passes the value to motion planning module, then we have ROS in place. In ROS, we have planners, motion planner libraries, and motion planning modules, and we can also write our custom motion planning modules. So all those modules will be taking information from our sensor information, the one that we have just created in front of you using ROS, right? So these will be utilized in creating the mission planner. What is a mission planner? It is actually deciding the long-term path, which highway to take, as I mentioned. Then the behavior planner. Behavior planner would be that if the vehicle in front of me is braking, then I should evidently brake. So this is a behavior planner. Then comes the local planner. Should I take the right turn? Should I not take the right turn and take the right turn from next junction? Something like that. These local planners, or should I change the lane or not? So these are some ego vehicle specific decision makings, which we can write our custom nodes in ROS. What else we can do is utilize any existing libraries. Someone might, as Mudassir mentioned, that ROS is about having a community and reutilizing the code base of other people. So we can also do that. So then after the planning module comes the control module. Right now we have just created the plan that what routes do we have to follow. Next step is actually following that route to performing the actuation. That's where the vehicle controller module comes in. So vehicle controller module is actually provides actually the steering information and the velocity control information. So if anyone is from the domain, they would know that these informations are basically the throttle information and the steering information. Steer is going to be in form of angles, and throttle is basically, if you have driven a vehicle, you know that you are just throttling the accelerator, and uh, you are just controlling the throttle valve, or the sorry, the gas valve of the vehicle. So that's what the throttle is all about. So these things combine in conjunction actually helps the gears, throttles, braking system to operate together and perform the vehicle actuation action. So this is also done using ROS, and ROS is actually responsible for communicating the decision that was made by the planning module, map it to the actual values required for the throttle, where the throttle valve is required to be, and then actually perform that actuation. So whole ROS is present in all these 5 or 6 modules that I have mentioned. And if anyone thinks that, okay, so if I learn ROS, it is I'm going to implement a self-driving vehicle, I would say that it's of course not the case. Sadly, there are some modules which would not be utilizing ROS. There are system supervisor modules, there are safety modules, but of course it has a very huge what should I say, contribution in accelerating the development of a vehicle, of an autonomous vehicle. So I hope I was able to just deliver that how what ROS is, what are the modules of an AV, and how we are utilizing ROS in different modules. What I tried to do was show one of the module from one of the module and show you how it is creating a map which will be utilized in and where it will be utilized in whole autonomous vehicle structure. So if I'm going to go back to the since I was on this page, I was not seeing the chats. So if anyone has any question, I would love to answer. And if there's any ambiguity in my words, I would actually like to clear it or emphasize more on it. So you can leave your questions maybe. Okay, so um, what I'm going to do after that, I'm going to show you that these are the values that we are actually grabbing from the sensor, and we are passing it to the map. So these are I guess these are scrolling so fast you might not be able to comprehend what it is saying, but I can tell you that this is an information coming from the RTAB map, which is a library of ROS, and it is showing that what point the mapping is on what actual point the mapping is currently going on. In addition to that, I am going to show you that the sensor, this is the RealSense camera node. So RealSense, when I launched the RealSense camera, it is as simple as executing one command, one liner command, nothing else. So this is what I executed, this one liner command, and everything was taken care by the ROS itself. The parameters, the all settings that were required for the map to be in place, they were mm, taken care of by ROS and RTAB map, and then we were able to pass those sensor informations to the mapping module. This one was the mapping module. It made utility of those sensor values and um, created the map for us. What else I can do is um, what I'm going to show you is when I say that sensor data is coming from one module and it is going to another module, what the part of ROS that takes care of this thing is called as ROS topics. So I just executed this command, which was ROS topic list, and it is showing me all the current topics that are being published, that are being utilized by this whole ROS infrastructure right now. So these are all the informations from camera sensor values. These are informations from its IMU sensor, inertial measurement unit. It is information from the filter outputs and all those things, from the depth sensor, from all those modules, and again from the RTAB map modules. And we are using all these informations to create what we just saw, the map of an environment. So I hope this was this intrigued some sort of an interest uh, in you people. I would love to answer any questions, or maybe we will move towards the end of the session. If anyone has any question. Mm, no? Okay. So as I mentioned that I will be talking talking very briefly about the AgriBot project of Smart City Lab, and I'm going to talk about. Okay, I have some question. Kindly inform regarding internship opportunities at my email address. Yes, certainly. I'm going to save your email address, and we are going to share it with our team, and we are going to get back to you. So, okay. Okay. So, I was mentioning about the AgriBot project. So in AgriBot also we have this use case of a um, very, what should I say, multi paradigm robot, which actually will be performing different agricultural activities, such as navigating through the agricultural lane and picking the weeds. So, weed removal is one of the use cases of our project. Then, in agricultural fields, the one of the utility is carrying um, the weights of heavy weights objects, I would say. When I say objects, I mean that fruits or anything, the cultivation outputs, I would say. So it is a requirement to carry those things from a very from the agricultural field all the way towards a destination, to the warehouse or any storage position, or to some other place. So there's a whole field that needs to be actuated, and then there's a whole field that is there's a destination that needs to be reached. So this all again involves various sensors, just like I mentioned, whole infrastructure in autonomous vehicle. There's whole infrastructure in agribot, and we are again utilizing ROS to actuate the vehicle, uh, and we will actually be, so I guess this what I'm going to say now is going to be more fascinating for all of you. We have our human sized robot, or actually not even human sized, it is next or comparable to the size of a Mars rover. We have that vehicle, that rover in place, and we will be doing our last two modules of the course on that vehicle. So you will be actually able to develop the algorithms that you will be learning throughout the course, and you will be able to implement those on, or see the working of those ROS infrastructure actually playing the part in actuation of that rover. So we will be utilizing whatever knowledge base generally the students of universities have that might be Arduino, Raspberry Pi, and we will be showing that how ROS connects to Arduino or Raspberry Pi and utilize the same knowledge base that we have coming from that embedded system or IoT system information system, and utilize it to work with ROS and make heavy vehicles and actuators move. So I guess this is it for the session. If there is any further questions that I could answer, I would love to. Or maybe we would just finish the session. So I guess you people are part of the group, so you people can send your queries on Smart City Lab Facebook page, Smart City Lab Instagram, or any other social media platform. You can also contact CERT for any information. If you are interested in enrolling for the course, you can contact CERT for the financial matters and the payment matters. If you have further any queries about the curriculum, you can contact Smart City Lab on email address and any other platform. So I guess I'll conclude this session by saying that it is a very ROS is a very dynamic and very powerful platform. It is I won't say very essential to have, essential to learn, or I don't want to say that if you don't learn ROS, you won't be able to do things. You would be certainly. But this skill set is a very unique skill set that I believe every hardware and software engineer should have in their toolbox, in their personal skill set toolbox. So, having said that, I guess um, this is it. Uh, um, uh, Mudassir, do you have any closing remarks?
Thank you to all of you to having here. It was a nice discussion or a workshop webinar on ROS. So I just say that if you want to learn a ROS, you just enroll in this workshop. So you will not only learn the ROS, but also you will learn the basics of the Linux and the Python programming. So those who are worried about that we don't know how to code in Python programming and how we can do, so we can do easily. We will help you and we will guide you each step. So don't worry. So just go and become a part of this workshop, which will be start from next week. So the price is around 10,000 per person. So anyone who has any question about the workshop, so you can ask.
Okay,
So I
thank you,
will ask.
Mudassir.
Okay.
Um, so the name of workshop is
Introduction to robot operating system.
the name of workshop is Introduction to ROS. I would Mudassir will just leave it in the comments. Um, Thank you everyone for joining. Um, I'll Okay. Thank you everyone. Okay, I'll end the meeting now.